Here is a piece of pie. Okay, so it's not pie, it's my quick, very rough diagram of a cross-section of the Earth. Now, let's go ahead and label and talk about the different layers of the Earth. Hopefully you're aware by now of some main layers like the core, the mantle, and the crust, and maybe you're aware that the core is actually split into two, the inner core and the outer core, and that's great. But that's only 4 layers, and yet I have more than 4 layers drawn here. So let's go ahead and break down what each of the layers actually is. It might help at the start if I just color in this part blue and I color in this part blue. What do you know that's, there's lots of on the surface of the Earth that's blue in color? That would be water, surely, right? Water is a very faint blue color. A lot of people think that it's actually colorless, but it's not. It's very faintly blue. So let's label this the ocean, because that is in fact what it is. Okay, so ocean on the right-hand side. There's also more ocean on the left-hand side. I won't bother labeling them both, but the point is there's something sticking up out of the ocean. Well, that must be some sort of land mass, surely, right? So this big bit sticking up, this is a continent. So I'll just go ahead. I'll try to keep talking as I'm writing or scribbling. Hopefully you can read my scribbles, but like I say, I'm talking about it at the same time. So if you can't read my scribbles, listen to what I'm saying. So we have the ocean, we have a continent sticking up. Now, this continent, this area here, also goes down underneath the ocean, doesn't it? That's because that is the crust. So where the continent is, but also that part just there underneath the ocean is the crust. So let's label. Remember, we're going to be labeling and talking about as we go through. Now, what sort of rocks are in the crust? Well, different types of rocks, quite a few types, but the main two are granite and basalt. So we have the crust is great proportion. It's granite. Oh, that's an E there. There we go. Granite and basaltic rocks. Is what the crust is largely composed of. Now, how thick does the crust get? Well, it ranges, it varies, anywhere from 0 to 100 kilometers thick. So let's go ahead and put that in here. Let's just go like this over to the side of the crust label. It's we're going from 0 to 100 kilometers thick. Now, it's not very thick under the ocean. So let's just say, we'll call it oceanic crust. Okay, so crust under the ocean is oceanic crust, and the continents we call continental. So we have under the ocean, it's about that little squiggle there. If you were typing this thing up, you'd probably find it next to the 1. You'd hit the shift and then the key next to the 1. That's tilde, and it just generally means about or approximately. So it's about 5 kilometers thick. This is under the ocean, so oceanic crust. So about 5 kilometers for oceanic. And in terms of the continental crust, let's put a comma there. Oh, did that work? Oh, yep, there we go. Continental crust, the average is about 35 kilometers, about that. So let's write continental. So it's thicker than the oceanic crust, but it does actually get quite thick as well, especially under the mountain ranges. So the continental average is about 30 kilometers thick. Okay, but like I said, under mountain ranges, it can get up to about 100 kilometers or so. So let's actually write that. So average about 30 kilometers. Let's just draw an arrow there, up to, what are we saying, about 100 kilometers thick under mountains. Roughly. These are fairly rough numbers. Like under the Himalayan mountain ranges. It's about 90 kilometers under the Central Valley in California, nice flat area. It's down to about 20 kilometers thick. So, better put an S on there. Under mountains. There we go. So we have on our piece of pie / cross section of the Earth, we've labeled the ocean and continent. These are both part of the crust, whether this is crust underneath the ocean. The crust is granite and basaltic rocks, ranges from sort of 0 to 100 kilometers thick, about 5 kilometers thick under the ocean for the oceanic crust, and the continental crust averages around 30 to 35 kilometers. It gets up to sort of 90 to 100 kilometers thick under the mountains, and under the flat plains it can be much thinner. Grand, that's the crust. Now let's change back to red, and we'll move on to the other parts of the Earth that hopefully you've heard of. So we had the crust. Under the crust is the mantle. Under the mantle is the core. But remember, we have more than 4 layers here. Okay, so let's go and label the core. But the core itself is divided up into 2 parts, the inner core and the outer core. So this region down near the bottom, this is the inner core, the innermost part of the planet, the inner core, and then above that we have, funnily enough, the outer core. Goodness me, my scribbles are terrible tonight. Oh well, like I said, if you can't read it, listen to me, you'll be grand. Now, these are both making up the core, of course, so the bottom part and the part just above it, that would be the core as a whole. So sometimes we just talk about the core, but scientists generally differentiate between the inner core and the outer core because they are different, as we'll see shortly. They're made of similar stuff. They have a fairly similar composition, but essentially one's liquid, one's solid, so they are really quite different. Now, so there's the core, and we've done the crust, and that means the missing part is the mantle, but you'll notice there are still, what have we got, 1, 2, 3 more layers to go. But that's okay, we can do that. But yes, those 3 layers make up the mantle. So we're going from here, from the bottom of the crust, that all the way down to the top of the core. This is all the mantle. You've probably heard of magma before. Well, this is where you're going to find the magma, right? Magma in the mantle. Now, we said what sort of rocks make up the crust. We've got the granite and basaltic rocks. So let's say what sort of things make up the mantle. Well, the mantle is largely silicate material. So let's zoom in. Silicate. And it's called silicate material because it contains silicon and oxygen. What are we doing? Silicate material, that's what we're saying. So if you ever see silica, you think, oh, silicon, all right? So it contains silicon. And the 8, silicate, right, that says that it's got some oxygen there as well. Si04 with a little 4 minus there. Now you probably don't need to know the formula for silicate, so don't stress about that, but just do know that the mantle is made of silicate material. Okay, and that silicate material just means that it contains SiO4. That's the silicate stuff there. Okay, grand. Oh wait, we didn't say what the core is made of. We've got the crust, granite and basaltic rocks. The mantle is silicate material. What is the core? What's that composition all about? Well, this is actually mostly iron. The core is iron. When the planet formed, the heavy elements sank down because they're heavy and dense. They sank down to the middle of the planet. So the core is largely iron. It also has, well, we think, some nickel and sulfur. So iron with some nickel and sulfur. There we go. So we have the main layers, which, like I said at the start, you've probably come across. The crust, the mantle, and the core. The core we differentiate into the inner core and the outer core. We've said what each one is composed of. So the core is iron and some nickel and sulfur. The mantle, silicate material, it's got SiO4. And the crust is largely granite and basaltic rocks. We've also talked about how thick the crust is. It can get really thick under mountain ranges, sort of up to 100 kilometers thick, down to sort of 20 or so in some areas, and under oceanic crust it can be just 5 kilometers thick. Okay, cool. Now we've got more to say because this diagram is far from complete. Where shall we go now? How about we go down to some depths, because we've given the thickness of the crust, but how thick is the mantle? How deep does it go? So let's go there. Let's label, oh, that didn't work. There we go. Let's label, hey, why are you drawing? Should be zooming in. Technical difficulties. Let's go to red. Let's draw. Let's erase. Let's use fingers. There we go. Okay, don't know why that was happening, but we're back on track. The bottom of the mantle goes down to about 2,900 kilometers, nearly 3,000. Okay, so the mantle reaches down to about 2,900 kilometers deep. And then we have the outer core. That goes down to 5,100 kilometers, so 5,100 kilometers deep. And then the bottom of the inner core, well, that has to be the center of the planet, doesn't it? And with a diameter of roughly 12,756 kilometers, that makes the radius down to the center 6,378 kilometers deep. So there you go. If you fell into the core, you would be falling for a very long time, because you would have to fall nearly 6,500 kilometers. It's, you know, a big planet, yeah? Right, so we've got some depths. Now, we should probably talk about the rigidity of each layer, just how solid, or maybe, as the case may be, not solid, is each layer. All right, so let's start with the continent. Now, we're not going to call it solid. What we're going to say is rigid. It is rigid. It is a solid, obviously. You know, walk outside and walk on the ground, and you don't sink down into it. You don't, you know, sink down into the rocks because they're really solid, right? But let's just call them rigid for now, and I'll explain why in just a sec. The very next layer, which is part of the mantle, right? So the mantle went down to the bottom of the crust, but the next layer, the top part of the mantle, is also rigid. Grand. Now, let's go right down to the inner core. Also rigid. The inner core is solid. But the outer core is actually liquid. So remember I said they are actually different, although they're both primarily iron. We have some nickel, some sulfur in there. They are quite different because the outer core is liquid and spinning around the outside of the inner core, and the inner core is solid. Now, the inner core is hotter, of course, hotter than the outer core. So, you know, you think maybe, well, actually, it should be a liquid, because, you know, if the outer core is a liquid and the inner core is even hotter, then, you know, if you heat your solid, it melts, you've got your liquid. If you keep heating it, it doesn't go back to solid again. It's crazy. Except actually, in this case, it does. And that's because of the enormous pressure of the rest of the Earth pushing down on it. So the temperature is such that, well, actually, yeah, it could be a liquid, because the temperature is about 6,000 degrees Celsius and iron would have melted. But because it's got the weight of all the rest of the mass of the Earth pushing down on it, all that very great pressure stops the core from being molten. So yeah, the inner core is rigid, it is solid. The outer core is liquid. That's really important because that spinning liquid outer core gives the Earth the magnetic field which protects us from harmful solar wind, harmful radiation from the sun. So that's really quite important that the outer core is actually a liquid. But remember these parts up here, we missed a bit. So is it solid? Is it liquid? Well, it's not gas. Well, actually, here's a word for you. These two remaining layers are plastic. Now, this does not mean that they are made of plastic. This is not a Lego Earth. Plastic in nature, or we say the rock has plasticized, technically it is still a solid, but it's like a semi-solid. Let's write it as a semi-solid. So this word plastic, or being plastic in nature, or the rock is plasticized, and the layer above is also plastic. What this really means is that this rock here can flow as if it were a fluid. So it doesn't crack or fracture. It flows like a very thick, viscous fluid. All right. So, you know, you're running honey after someone's put it into the fridge, right? You go to make your toast and you go, hey, where's the honey? Oh, some idiot put it in the fridge. You take it out. It doesn't come out very easily, does it? But it is technically still, you know, honey. It will flow out, but it flows very slowly. Well, that's kind of what this stuff is here. It's plastic in nature. The rock is plasticized. It is not melted. It's not molten rock because it's not a liquid. It is technically still a solid, but it flows as if it were a fluid. So yeah, it flows like a very thick syrup kind of thing. So the word is plastic there. It's like a semi-solid. All right, grand. Now, actually, I was putting some depths. Let's put another depth in here. 700 here, 700 kilometers down for that second part of the mantle. And we'll label that part of the mantle shortly. So what we have now, if we just zoom out, oh, that was too far, zoom in a bit, try and fill your screen, there we go. So we've labeled the layers of the earth, the core, which is the inner and the outer core. We've got the mantle. It's actually three parts of the mantle we'll go over in a sec, and the crust. And we've talked about the composition of each of those layers. And we've talked about the rigidity of each layer. So the crust is rigid, the inner core is rigid, the outer core is liquid, and some parts of the mantle are rigid. That top layer is rigid, but then below that layer, it's plastic in nature. So sort of like a semi-solid. And there is a reason why we've broken that up, that plastic part of the mantle, into two distinct layers, and we'll get to that in a sec. But first, let's talk about, what should we talk about? The lithosphere. There we go, let's talk about that. What color do I want? Let's go back to red, I guess. Now, the lithosphere is the crust and the very top part of the mantle. So the lithosphere is the crust here down to here, the top part of the mantle. So this is the, give me enough writing room, lithosphere. The crust and the top part of the mantle. In fact, let's let's write that because we can. Where's some space? Oh, plenty of space over here. So lithosphere, this is the crust and the upper mantle. Now, the uppermost mantle, but which part of it? It's the uppermost, it's the solid part of the mantle, that rigid part. So that's the lithosphere. Now, shall we learn some Greek? Yes, let's do that. Let's learn some Greek. I'll just actually throw this down the bottom somewhere. Lithosphere, because lithos is Greek for stone. So remember, this is the hard, the solid, the rigid part of the mantle, right? So this term lithos is Greek for stone. So it's the, what we normally think of as hard, solid, right? Here's another bit of Greek for you, asthenes, because we're going to meet asthenes in a sec. So lithos is Greek for stone. Asthenes Oh, what happened to that S? I don't know. It's all right. We can erase. Try again. Asthenes is Greek for weak. So there we go. Lithos is Greek for stone. Asthenes is Greek for weak. So we have up here somewhere, there you are, the lithosphere. Okay, lithos, stone, hard. It's the crust and the solid part of the mantle, not the plastic rock of the mantle, not that stuff that can flow like a fluid. All right, so that's the lithosphere, grand. Now underneath that, this next section, which goes down to 700 kilometers, this is the, let's use our Greek, asthenosphere. All right, so the lithosphere is where it's hard and what we would think of as normal solid. And then underneath that, we have the asthenosphere. Asthenosphere. So remember, asthenes meaning weak, because the rock is not, solid, strong, good, healthy rock. It's weak. It flows. Rock shouldn't be doing that. So, weak rock. Yeah. Now, you may have covered at some stage about convection currents in the mantle. This is where they are. So it's the asthenosphere, which is where the convection currents occur. Okay, cool. Oh, and you may have covered that the outside surface of the Earth is not a nice solid single surface. It's broken up into plates. All right, and the plates are sitting on top of those moving convection currents, but it's not crustal plates. It's not the crust that is broken into these plates. It's the hard rock, wherever there's the hard rock on the top. Well, that's the lithosphere, isn't it? So we talk about lithospheric plates. Okay, or the plates are the lithosphere, it's not just the crust. Anyway, grand, moving on. That's the lithosphere and the asthenosphere. Let's label the other part of the mantle. That is this part here. This is the mesosphere. Now, meso just means middle. Okay, so we know why it's called lithosphere. Lithos for stone. We know why it's called the asthenosphere for weak rock. Mesosphere, well, meso just means in the middle. It's kind of like in the middle, isn't it? So that kind of makes sense. Sometimes science just makes sense, which is quite nice. So there we go. There are, I guess, all the different layers labeled, but we'll mention two other things. What color shall we go? We've used red and blue. Oh, we haven't used much blue, probably because it was a blue diagram to start with, but that's okay. We'll go back to blue. You know what? We won't. Let's mix it up. Let's change and choose, I don't know, purple. There you go. I do know we're going purple. Cool. Now, we have between the mantle and the core, so that would be right here. All right, separating the mantle and the core. This region is known as the Gutenberg Discontinuity. Give it a capital G when you're writing it, because named after a person. So it's the Gutenberg Discontinuity, meaning it's it's not continuous, it changes, right? So there's a very noticeable change. So it's the Gutenberg Discontinuity. There we go. Just sound it out and you can spell it. Well, hopefully you can spell it. It's always nice to be able to spell things in science, but give it a good go, at least. And so that's the Gutenberg discontinuity, where the mantle cuts off and becomes the core, switches over to the core. And we have another one, the Moho discontinuity. People usually refer to it as the Moho, or the Moho discontinuity. It's actually the Mohorovicic discontinuity, named after a Croatian man, but I guess people have trouble saying Mohorovicic. So they just say the Moho. But anyway, where is this? Well, this is between the crust and the mantle. And that puts us right here. So between the crust and the mantle there, that is the, the Moho, right? It's what people often call it, but actually it's the Moho Discontinuity. Now that C is not a C like you'd want to say maybe Vikic or something, but it's actually like a CH. So it's Moho Discontinuity. Let's write the whole thing. Discontinuity. Right, so I think I'm about done. I think that's all I want to label of the cross-section of the Earth. Let's make it fill your screen. There you go, that should be filling your screen now. So there we go, our piece of pie is now turned officially into the a cross-section of the Earth. So we've labelled the parts, we've talked about the composition of the parts, we've talked about the rigidity or the plastic nature or the liquid nature of certain parts, and we've talked about lithosphere, asthenosphere, and we labelled the mesosphere, and we talked about a couple of discontinuities where things really just start changing. So there we go. That, in a nutshell, is a cross-section of the Earth.
Hey you, hit the like button. Yeah, and the subscribe one too. Yay!